Hey everybody, welcome back. I'm Deez, this is my workshop. Today we're going to have a simple project, but I want to share it with you because I think it's something everybody can do and you might as well do it. What we're going to do is create a cover for the mill vise in order to keep chips and debris out of the screw, the feed screw, the lead screw, whatever you want to call it, for the vise, for the movable jaw. Why are we doing that? Well, number one, we don't want to get chips and everything down in the screw because it can affect accuracy, precision, performance, and all that crap. But beside that, I've now got the power feed unit, and the power feed unit has a auto stop function that mounts a switch that mounts down here underneath the vise. Well, as I'm using this, chips are going to go down in here, and I don't want them to get onto the switch. Well, the switch has this nice protective cover on it, but that impedes its functionality. It causes an issue. I think it gets bound up being underneath the vise, and so it rocks, it doesn't actually stop. It's okay, and in the instructions, to take this cover off if you want. It's not necessary, and I tested all of the moving functionality of this, and it works great without this cover. The problem is, if I don't leave the cover on, now I'm looking at debris and chips and everything getting down on top of it and potentially ruining it or causing issues because debris can get down on top of it. So I want to avoid that, and the solution is to create a rubber. I'll use this neoprene rubber in order to cover this piece, and it'll kind of hang over a little bit and be able to travel back and forth. It's going to be pretty simple. I'm just going to use a piece of flat stock, mount into these screw holes to pinch the rubber on here, and should be a pretty simple project, really good upgrade to the mill, and allow me to use this switch without the need of keeping that cover on there, because if I ever want to use it, I got to take that cover off of it, and I can't take it off without removing the whole thing. So the idea is to get everything mounted so you don't have to do all that. The first thing we're going to do, well, I've already done it, is take this switch back off. But the other thing that's an issue, when I put in these stops, they work really well, but they get bound up when you tighten them up, and I think it's because I never really cleaned out. See how I've got that loose, but it won't just slide out of there. It should move. It shouldn't bind up like that. And I think the problem is there's cosmoline still. See, I can't. There's still cosmoline stuck inside the tracks. So if I take this out of there, that doesn't move until I kind of move it back and forth, get it to rock. There, now it comes out of there. So it's getting stuck and bound up. Now I don't know if it's the build of these or if there's cosmoline, but I want to get these channels cleaned out so that these things will move freely without needing to take them off every single time. So that's the next step. Get that out of there, and we're going to clean the cosmoline and dirt and debris out of this channel. I'll bring you in closer for a look. Hopefully you can see all this. What we're doing is taking these brackets off. I already took one of the stops off. Let's take this one off. Pretty simple. They just screw on there, and they've got these wedge pieces that allow you to slide them on and off. Of course, I have to slide this one all the way down to this side. Problem is that won't come out of there now. I don't think this will fit, will it? Yeah. You got to kind of rock this piece to get it loose. Now again, I don't know if it's the cosmoline or dirt, but the first thing I'm going to try is to clean all of this channel out. I never did that when I first got this thing. So if you remember, what really cleans up that cosmoline, just dissolves it, is WD-40. So that's what I'm going to use. We're just going to spray some into this channel and try to get everything cleaned up. Move that out of the way. And there's still cosmoline there. I don't know if you can see it, but we'll just spray some of that in there. That'll clean right off. So that's the idea. We just want to try to get this cleaned out. I want to let it sit for a minute there. I do want to let it sit for a bit, just to let it dissolve any of that cosmoline. But that's the idea. We want to clean this out. Hopefully, if there's any burrs too, I can clean those out, and then we can get these little pieces to slide in and out more free. It could also be that the chamfer on these doesn't quite match up, so it's binding up. That's probably part of it. Yeah, I don't know. We'll see. But we'll just let that sit and drip a little bit. Yeah, there you go. So you can see that cosmoline, that yellow, comes right off of there. If you ever get a machine with it's just caked in it, it's like a really hard looking yellow varnish, and WD-40 just takes it right off. Let's see. Let's get this in here. I'm sure there's some, still some, like, burrs and things like that from when original manufacturing. I didn't clean this as well as I should, admittedly. It wasn't really a piece of the mill that I was using right away, but now I have a reason to use it, so I'd like to get this sorted out. Let's just keep cleaning it up. It's pretty dirty, that's for sure, so that's one thing. Probably should have done this before I mounted the power feed. Go. See if that did anything for us. I know they'll slide in like that, but I think it's just going to be the nature of these things to bind up the way, because they're a little too small, but kind of is what it is. Let's I just wanted to mostly get that cleaned up. I just won't crank them down too tight as they're sitting there until I'm ready to use them. Yeah, once this is on there, they get tough. They don't, whatever they are, they don't, these little mechanisms don't want to slide very well. I'll just keep that in mind. Maybe I'll remake these pieces someday. These little wedge pieces. We'll put that one back over here. Let's see, it does want to bind up. There we go. So we'll get these put back on, and then we will continue on with making the cover for the mill vise. I do want to clean that up as well. I'm going to use some compressed air and get that cleaned up. You can kind of see down in there, but there's all kinds of dirt and grime in there. I'm going to try my best to clean that out. We'll vacuum it up. You know, a lot of aluminum, things like that. I just want to get that as clean as we can. It ain't going to be perfect. And then we'll proceed with making the piece that will cover all of this. But, you know, anybody with one of these is going to understand how that is. Maybe before I even put this on, I should have created something, but it's fine. We'll get this cleaned up and we'll get to making this piece. First thing I want to do is see if I can jam this down in there and clean up some of those chips. A little better. Let's back this out now. I want to do this as best I can before I go and run my air compressor in there and make a huge mess. Which I would really never use the vise with it backed out this far unless I'm milling something all the way on the front side. I don't have enough travel to use it like this, but you can see, you can't see, there's all kinds of debris in there. Let me show you real quick. So you can see the debris that's down in there. So we're going to try to vacuum that up. I'll agitate it with the brush and see if we can get most of that out of there. Actually cleaned up a lot better than I thought it would. Lead screw's still got some oil and a little bit on there, but I think I can clean that up too. Yeah, that's not too bad. Now we'll go ahead and spray this, blow this off with some air, get the rest of those chips out, and then we'll be ready to get something fashioned here to prevent chips from getting down in this side. Now they'll get on this side, but they won't get down on this side. I don't have a fancy mill vise that actually has a cover in here. That would be really nice. Probably make something, but for now, I'm just going to cover the back side of it because my goal is really to keep debris off of the switch. So let me get some air and we'll blow this out. Here's what I came up with. I've got this scrap when I put the neoprene on here. It just so happened that the size of that is perfect to what I'm trying to achieve. It's just a little long. But the idea is to pinch this back here, mount it with a piece of bar stock, and I happen to have this piece left over from my first design of my lathe carriage stop. That's going to work. I'll just need to cut it down a little shorter, and that will screw in and pinch this neoprene into place. And then I'll cut this to length. Once this is fully retracted, I'll get this nice and hang over. That way there can't, at least on this back side, I'm not going to get chips and debris down into this channel. So this is going to be the piece I'm using for that. This was the scrap, again, I made out of my carriage stop, the first clamp style that I made, and we're gonna get that drilled. They're just gonna be through holes. Simple project. But the critical part is I gotta get the distance between these two measured. Finally, we need to determine what the thread size for these are. And I bought a tool for that. Well, I think I know what they are, but I'm gonna use the tool that I bought just to show you, demonstrate that there's all kinds of different things out there, different ways to achieve your goals and what you're trying to find out. All right, so we have my thread checker. These are for inside and outside nuts and bolts, nut and bolt thread checker. This is going to be metric because this came from China. It's going to be roughly, wouldn't be quarter 20, it'd be M5, M6, M7. Let's try an M5. Nope, that's too big. Let's try M6 1.0. And there we go. That goes in there real nice. So we know this is M6. So I need an M6 cap head screw. M6 1.0 thread. This was pretty affordable. I thought about making a set myself, but this was so affordable and handy that I thought I'm not going to bother with that. It has the opposite side as well. I have some M6 screws here. Of course, we can check it in here. But these thread checkers are really cool because you can, if you're trying to determine what threads you need, you can thread them in as you see fit. And now you know it's an M6. Not sure what length we're going to need yet. We will determine that later, but we'll double check it by threading in M6 here. And that threads in real nice. So I've got varying lengths of M6. I just bought a pack of M6 a while back for another project. So this is going to work out nice that I have these ready to go. And now we just need to get on with measuring the distance between these two and go ahead and get this mounted into our vise or our mill and get the holes drilled. We've got you brought back here. So the next thing we need to do is just drill some holes in this piece, do some chamfering, cut it to length, and then we're done, really. Pretty simple project. But what I wanted to do was do some measuring. This one's a little bit too long, this flat bar that I'm going to use. It's 3 3/4 inches wide. So what we want to do is cut that down 3 3/4 inch. I'm going to leave a little extra so I can mill off the edges so that they're square. And then once that's done, I measured the holes. Now, they're not completely centered on the vise. And so, you know, we're just going to kind of get them as close as we can. Fortunately, they're just through holes, so this shouldn't be too difficult. What we're looking is the outside to the outside is 2.7 inches, 2.707. And the inside to inside is 2.3025, and that leaves about 0.2 200 thou or so width. Now I know that's going to be a little more than that because of the thickness of the threads on the M6. So we're going to choose the appropriate drill so that we have a through hole. These will probably be slightly larger than they need to be, but that's because I need to, you know, line these up from side to side. This is why I measured from the outside of the right side hole to the edge of the vise, and we're at 0.529, and we're about 10 thou out completely on the outside of the left side hole to the outside of the vise. So they aren't completely centered. 10 thou is not that big a deal. This part's not big a deal. It's really is not critical at all. But I do want to get it close, so we clamp it in there. It's nice and tight, and it doesn't go anywhere. So I think what we need to do next is measure the size of the threads of the M6 bolts we're going to use, and then determine our drill size, and then mark this piece, cut it to length, and then mark where our holes are going to be. Let's get one of these M6s out of here that we'll probably use. Be these guys here. Measure a couple. So we want to drill that it's at least 2.3 thou. Let's check this one. 2.3. So we're going to use a drill bit that's at least 2.3 thou. That would be that'd be a 15/64. I might actually just go up to a quarter and be done with it. That way I got plenty of room inside those holes. But what we want to do now is mark our 2 3/4 length. I'm going to go a little strong, like I said, because I want to mill the ends to make them nice and square. So 2 3/4, or sorry, 3 3/4. That's going to put us out to here, but we want a little bit longer. I'm going to go 7/8. So we're going to cut that on the bandsaw. If you hear that jump, we need to change this blade. It's pretty bad. I don't know if I can spin that or not, but there's a bad spot in this blade somewhere. We got our piece cut out. We're going to mill the edges, and then we'll mark out where the holes will be drilled. Parallels put in here. We need them over here, and then we will mount this. We're going to face off both of these edges. We'll measure the total length once we get one side done, and do a little bit of tapping. I think my vise here has got a little bit of jaw lift. I'm gonna have to look at that someday. It's not a high quality vise, but when I tighten it down, I think this jaw, the movable jaw lifts, because it always ends up seeming to come loose a little bit. Since this is not critical, I'm not going to worry about it too much today. But that's something that I want to address someday. But let's get this end faced up. That's good. Let's flip this around and do the other side. We will measure 3 3/4 before we make the next cut. We'll see how much we need to take off. Okay, 3 3/4. We got a bit to take off, not too much. Right there. That'll give me a mark to work towards. How did we do? That did all right, but we still have, I don't know, 1/8 of an inch to go. There we go. That is what I wanted, right on the money. Visually, anyway. The next thing, something I want to check before we move on, I want to make sure the height, if I center the holes to drill, are they going to be, I don't want this to sit proud of the top of this. Who knows, I may need to mount something, take this jaw off and put it back here and mount this differently. I suppose if I ever did that, it would be, I would remove that, but regardless, I want to, I would like that to be lower than the back of this movable jaw. So I'm going to do some measuring and make sure before we mark for our holes. All right, we want to come 400 thou is where we want that to be. Since I've got it here, yeah, we'll do it here. About where we want that. Same over here. So I want to come in here 630 thou. $650. And there we go. So we've got our 2 holes marked. We're just going to drill those for a 1/4 inch. Take a look, see where we're at. That's pretty good. Got one done. Let's bring her down here. Watch this. And just like that. I like it. Let's eagle eye that too. That's pretty good right there. Maybe come back just a little. I like it. Let's get another hole drilled. Now, with any luck, these will fit in there just fine and dandy. We got some deburring to do. There's our piece. Again, I'll do some filing on some of the other edges, but for now, let's see how we did. Let me get a M6 bolt. Here's a couple M6 bolts. This will mount in here. That works. How do we do? Oh yeah, that looks good. Beautiful. That's nice. I got a little more deburring to do on the edges, soften some of these edges, but the next thing we need to do is mark where the holes are going to be on the rubber. We'll drill a hole in the rubber, kind of get those to where everything can mount up, and then we'll cut the rubber to length. It's good. Works good. I'm going to do a little bit of deburring off camera. There's no sense in seeing that. I'm just going to use a file, and then we'll get the rubber up here and mark that. This is going to be very unscientific. I think what I'm going to do is have it actually protrude up a little bit, and I'll trim it off later. And the length I don't care about, but what's important to me is getting it squared up. So I think I'm going to give myself plenty of material to cut off at the top. And then that way it doesn't matter so much where this ends up being. So I guess, if anything, actually, I'll just do this on a block of wood. That's going to be a better idea. Since we have so much extra material, I'm just going to come down, giving myself plenty of room to work with. I'm going to put this on top, and we're just going to drill a hole in that rubber. Like I said, then we can cut it later. We'll put a screw in there to help line it up. But for now, do that, put the screw in here, line that up. Well, we got those holes drilled. They're a little, actually I think I'm going to leave them that way. They're a little undersized, but that will help secure this, I think. But we've got, there's our part. Still got scale and everything on there. Maybe someday I'll clean that up and hot glue it. You know how I like to hot glue things. It's definitely too long and definitely needs trimmed down. But the next thing we need to do is get this test fit on there and make a mark where we can cut this down. Let's see how we did. There's one side. Let me get a Allen screw here. we want to get this screwed in here. I may need to get a longer Allen screw, but I'm going to try to go with the short ones first. So it's just peeking through there, but we may need to get a longer Allen screw. Kind of thinking, let's go ahead and do that. I'll get both of these started, and then we'll screw it to the vise. There we go. So this is the idea. This one should go in there. Yep. This is almost, there we go. There we go. It's good. It's going to work out really well. So I'm going to tighten this down. Now, one thing I don't like is we want to make sure before we tighten it down that we get this centered, you know, kind of how we want it. I mean, it's a little tight right now. I can adjust it once it's on there. That way it's, you know, right where it needs to be, covering basically the entire vise. But there we go. Let's get that tightened down. So it's obviously too long. It's all the way up. Let's measure exactly how long we need this thing. If I was to use my quick rapid handle, I don't need any more length than to here. About like that. That will work. That's great. That's what I wanted. I wanted this to sit below the top of this. So the next thing we need to do is cut this piece off, and then we'll do our mount test. I think I'm just going to use scissors on this. Nah, that wouldn't be right. Let's cut it. That's too long anyway. Let's cut it back here. We're going to do it like that. There we go. Too worried about that. There is the protective cover. Yeah. That's going to work well. Next thing we need to do is put our switch back on and make sure that fits, and that will be a project to a close. Works really well. I just thought I'd give you a quick close-up. I'm cleaning up the parts from taking the left x-axis table feed handle off, and the middle of the table, there's an indicator, this piece here, that you can point to 0. It just kind of tells you where the center of the table is. It mounts to the undercarriage, I suppose you call it, where the x-axis sits on top. And I just thought I would share that I was checking out this milling. This is Precision Matthews mill, but you know, I don't fault them for this, but even I could do a better job milling that piece. This is untouched by me. I just took it off and cleaned it up. So thought you'd like to see that. That's, you know, they could have done a little better job cleaning that up, but it doesn't matter in the long run. It's you'll never see it type piece, but I thought that was interesting how bad that is. Again, I'm not knocking Precision Matthews. This is the piece you see. It looks really nice on this face. Not an issue. I just thought that was interesting. I don't know if that was manually done or a machine did it. Automation type thing. I wanted to run the wire kind of down through there to get it out of the way. And then now we can mount this switch without those spacers. Here's the other one. Get that in there. There we go. And get that one on there. There's the switch. So how that works is when we have the power feed on, which I've shown in previous video, but if we got this going, and then I've got this bump stop put where I need it to be, it'll come over, hits this switch. Now it's done. We turn that off. If we go back the other way, if I have this one over here, put where I need it to be, it's going to hit this switch, and it stops. Now I've got this cover to keep the oil, dirt, and debris from tainting and contaminating this switch. That's going to work out really well. Well, everybody, I hope you enjoyed. That brings this project to a close. We've got our mill vise cover completed. That's going to keep dirt and debris and oil and all kinds of stuff from coming down onto the limit switch. That is for the power feed for the milling table. Small little upgrade, but a really cool thing. We'll just show you again. This mounts in here. It pinches on there. There's the screw, but we can bring this in and out. It'll keep all that oil, dirt, and debris from falling down into this limiting switch and contaminating it and causing issues. Overall, I think it's a worthy little upgrade. You can always remove this very easily. Simple little project. I encourage you all to make one of these yourselves or some variation of this. I hope you enjoyed, and I hope to see you on the next one. Thanks for watching, everybody.